There is an assumption that space is extremely cold, and that is mostly correct, with some caveats. It very much depends on where you are in outer space, so you wouldn't simply freeze without protection. There are cases where you might burn, and others where even a spacecraft would melt. So in this video, we're going to talk about how cold is space? The video is going to be amazing, so make sure you stick to the end. The baseline temperature of outer space is 2.7 kelvins, which is about minus 454.81 degrees Fahrenheit, or minus 270.45 degrees Celsius, meaning it's barely above absolute zero, the point at which molecular motion stops. But this temperature is not constant throughout the solar system. So-called empty space, though it's not actually empty, is far colder than planets, moons, or asteroids, for example, because there is practically nothing to absorb the energy coming from the sun. Cold is simply the absence of heat. Any spot in the universe that's sufficiently blocked from all heat sources will eventually cool down to freezing temperatures. But points in space removed from heat sources aren't cold, in the sense that they would quickly make you cold. Quick heat transfer requires contact or air, both lacking in space. As a result, objects cool very slowly through the much slower mechanism of thermal radiation. A human exposed to outer space in shadow without a spacesuit does not instantly freeze to a block of ice. The universe is so vast and filled with such a multitude of objects, some blisteringly hot and others unimaginably frigid, that it should be impossible to give space a single temperature. Yet, there is something that permeates the entirety of our universe with a temperature that is uniform to 1 part in 100,000. In fact, the difference is so insignificant that a change between a hot spot and a cold spot is just 0.000018 Kelvin. Before we move on, support us by hitting subscribe and the bell icon to get notified when we post new videos. Now, let's get back to our topic. The CMB is a remnant leftover from an event that occurred just 400,000 years after the Big Bang, called the Last Scattering. This was the point when the universe ceased to be opaque after electrons bonded to protons, forming hydrogen atoms, which stopped electrons from endlessly scattering light and enabling photons to freely travel. According to the National Aeronautics and Space Administration, the coldest place in the universe is the Boomerang Nebula. NASA reported that at a cosmologically crisp 1 degree Kelvin, the Boomerang Nebula takes the title of the coldest place in the known universe. 1 degree Kelvin translates to minus 458 degrees Fahrenheit, or approximately minus 272 degrees Celsius. For comparison, the coldest recorded temperature on Earth is minus 128.6 degrees Fahrenheit in Vostok, Antarctica. A nebula is a cloud or mist of gas and dust occurring in interstellar space, according to Britannica. Located 5,000 light-years away from Earth in the constellation Centaurus, the Boomerang Nebula is a relatively young planetary nebula, according to NASA. Planetary nebulae are stars in their end-of-life phases. These nebulae emit intense ultraviolet radiation, causing the gases to glow and produce vibrant colored light. Temperatures can be measured by observing the intensity of infrared and microwave radiation emitted from surfaces. Ian Crawford, a professor of planetary science and astrobiology at Birkbeck University of London in the United Kingdom, told Live Science in an email. In the absence of such measurements, temperatures can be estimated based on the amount of sunlight they receive. However, taking cosmic measurements isn't always simple. According to Don Polico, a professor of astronomy at the University of Warwick in the United Kingdom, nothing is ever straightforward in astronomy, mainly because you're always observing as opposed to interacting. So although there are accurate ways to measure temperature in space, there will always be room for refinement. Temperatures are estimates, Polico said. The numbers you calculate depend on how good your assumptions really are and how detailed the physical model is that you're using. If an astronaut were left adrift alone in space, then exposure to the near vacuum of space wouldn't freeze an astronaut as often depicted in science fiction. There are 3 ways for heat to transfer: conduction, which occurs through touch; convection, which happens when fluids transfer heat; and radiative, which occurs via radiation. Conduction and convection can't happen in empty space due to the lack of matter, and heat transfer occurs slowly by radiative processes alone. This means that heat doesn't transfer quickly in space. So that's it. Please like, share, and comment your thoughts below if you like this video. Remember to subscribe to see our next video. Stay safe, and we'll be back soon with another video.